Hello guys, welcome to Netexpertz. My name is Kapoor. So today we'll talk about IPv6 part 2. Okay, in the previous video we'll talk about IPv6 part 1. Okay, so if anyone is new in this video, I recommend you to please see part 1 and then you can go for part 2. Okay, so now let's start with the things. So we'll talk about the IPv6 part 2 means lecture 2. We already discussed about these things. IPv6 is a 128-bit address. In last video I already discussed these things. It has 8 segments. Why we call it a segment is why? Because octet has only 8 bits. Okay, one octet has only 8 bits, but in this we have 16 bits. So one segment is 16 bits. That's why we can call it a segment. Okay, so we have 8 segments in this. It works on hexadecimal format. Okay, hexadecimal is a you can say the number system. We have binary, decimal, hexadecimal, octet. Okay, so your IPv6 works in hexadecimal and your IPv4 works in decimal format. Now there is no classes in IPv6. Like in IPv4 we have classes, class A, B, C, D, E. There is no classes. Okay, so it's a classless IP. Okay, there is no classes. Now, no broadcast, as you already know that there is no broadcast in IPv6, it do any cast. Now, no backward incompatible. You can say that there is no backward compatibility. As you can say that backward compatibility means that if you have IPv4 machine and you have an IPv6 machine, so we're not able to communicate IPv4 to IPv6. Understood? Okay, so there is no backward compatibility in that. Fine. Now we'll talk about the conversion of hexadecimal to binary and binary to decimal. Okay, so as you can say that in IPv6 it works on hexadecimal, which we already discussed. Hexadecimal. So in this hexadecimal we have 4 bits. Okay, so if I need to convert any number, like imagine if you have a number 8, I want to convert them to hexadecimal. So hexadecimal works on 2 raised to power 4. Okay, so like this. So it means it has 16 bits. That's why I already told you we have 16 bits. So this is the bits. We consider number of it's a bits. Okay, so if go for 2 into 2 into 2 into 2 is equal to 16. That's why we can call hexadecimal as 16-bit address. Okay, because it has 2 raised to 4. Okay, so now 2 why we can represent 2 over there is because 2 is a binary. Okay, in your computer we work on binary, that's why. Okay, now we'll see the conversion. Like imagine that we already represent the hexadecimal numbers to 4 digits. Okay, like this. We have 1, 2, 3, 4, like this. Okay, now these has the values. Like number 1 is 2 to power 0, number 2 is 2 to power 1, number 3 is 2 to power 2, and number 3 is 2 to power 3. If you calculate these values, the answer is 1. 2 to power 0 is 1, 2 to power 1 is 2, 2 to power 2 is 4, and 2 to power 3 is 8, like this. Okay, fine. If you calculate all these things, so the total is, we have a 15. So in hexadecimal, we have 15 values, like this. If in hexadecimal, we can calculate over there is, imagine if I write hexadecimal numbers over there. Hexadecimal, okay. Over there, I'll convert the hexadecimal numbers in the binary. I'll show you how we can calculate all these stuffs. And then over there, we'll see the decimal format. Okay, now let's see. If I talk about the hexadecimal, so like imagine if I represent 0 in hexadecimal, okay, so in binary conversion, the 0 is like all the 4 digits are off. So go for like this. In binary, we can write 0 like this. In decimal, we can write 0 like this. Okay, now imagine that we have 1. Okay, this is the hexadecimal format. So go for 0 to 9 and then A to F. Okay, the total base value of hexadecimal is 15. It's 16 as you can say that. 16 bits. How is 16 bits? This is the bits wise. I'll showing you. Okay, so 0 to 1. Now 1. So you can calculate the 1. Now if I calculate 1, if I write 1 in binary, so how you can write 1? I need to on this bit only. I need to on this bit and off all the bits like this. So this is the 1 we have. Okay, so let's go for 1 over there is 0, 0, 0, 1, and in decimal we can write simple 1 like this. Okay, now we'll go for 2. So calculate the 2 over there is, so we need to off this bit, we need to on this bit, and we need to off this bit. Okay, so like this 0, 0, 1, 0, and in decimal we have 2 like this. Now in 3, so you go for, we need to on 0, 0, 2 plus 1. 3. So go for 1 and then 3 like this. Okay, we need to do plus only. Okay, like imagine that if you write 4 in the binary, so how we can go for that? 4. We have this value, digit is 4 only. Okay, this bit value is 4. So we off everything. We just simple on the second bit and then off like this. Okay, now we have a 5. So like this, 5, 4 plus 1, 5. So go for 1, 0, 1, 0. So 5. Okay, then go for 6. So 6 is 4 and plus 2, 6. We need to off first digit, first bit, second and third we need to on, and the fourth bit is off. Like this, we can go for 6. Now we can go for 7. So we need to on this. This is less than, so we can off first one. Then we can plus 4 plus 2 6 plus 1 7. So we can on like this, and this is 7. Then we can go for 8. So we have a first bit value is 8. We need to on one and then rest is off like 8. Okay, fine. This is the way. Now if you need to write 9 over there, so how we can represent 9 over there? 9. Okay, so the 9 is 8 plus 1, 9. So go for 1 0 0 1, and in decimal we can write 9. Now if we talk about the 10, so 0 to 9 is a numerical value in hexadecimal also. But if you need to write 10 in hexadecimal, so it's go for alphabetical like this. A is equal to 10 in hexadecimal. Okay, we can write A for 10. So what 10 like how? 1 0 1 0, and over there is 10, means 8 and 2 10. So the answer is 10 like this. Okay, now we can go for B. B is represent 11. Okay, so how we can go for 11? 8 plus 2 plus 1 like this. 1 0 1 1, and over there is 11. Now we go for C. Okay, C means 12 like this. So 12 1 1 0 0, and this is the 12. Okay, now D 13. So go for 1 1 0 1 and 13. Then E 14. Okay, in 14 how we can write over there? 14 means 8 plus 4 12 plus 2 14. So 1 1 1 0. Now 15 we can write F in hexadecimal for 15. So over there we can write 15 like this. Okay, and the answer the 15 is 8 plus 4 12 plus 2 14 and 1 15. So go for 1 1 1 1 like this. So this is the hexadecimal values converted to all the binaries. So your hexadecimal place value is always starts with 16. Okay. So now if you want to convert it, if you want to convert the digit, I'll give you the digit. Okay. Now I'll give you the numerical. I'll give you this example. Like imagine if I have a hexadecimal value like 2 1 AB. Okay. Now I need to convert this value in the binary. So how you can go for that? For 2, what is the value? Like you can calculate over there. We have 4 zeros. Go for 1, 2, 4, 8. Like 2 to power 0, 2 to power 1, 2 to power 2, and 2 to power 3. Like this. So if I need to write 2 in the binary, so what is the value? 0, 0, 1, 0. Like, right? If I need to write 1 over there, so the value is 0, 0, 0, 1. Like this. Now A, for A we can call 10 in the decimal, right? In hexadecimal, A is equal to 10. So the 10, how we can go for that? 1 0 1 0. Okay. Now how we can write B? B is 11. So 1 0 1 1 like this. This is the full calculation of this digit in binary. Okay. Fine. Now if you do opposite, like see. When we do opposite, like imagine I have a value like this 0 0 1 1 0 0 1 1 0 0 0 0 0 1 1 1 like this. Okay, now I need to convert them into the hexadecimal format. So how we can go for that? Calculate this first. This is the 4 digit 4 4 4. Make the 4 4 pair first. Okay. Now let's calculate in the binary. Okay, so how we can calculate in the binary? Like we already know, we have the digits. So over there first is 0 and then rest is 7. Okay, so the value of this is 7, right? Okay, now there is all are 0, it means the value is 0. Okay, and now we have this one, so the value is what? 3. Okay, and we have this one again, the value is 3. So this is the value we can go for that. Understood? Okay, like imagine that if you have like this, Like imagine if you have like this 1 1 1 0. So how you can call it? Like now calculate. 3 digits on, 3 bits on, so means 8 plus 4, 12 plus 2, 14. So how we can write 14 in the hexadecimal, like A is equal to 10, B is equal to 11, C is equal to 12, and D is equal to 13, and E is equal to 14. So we can write E only. That's it. So this is what we have: the hexadecimal to binary conversion and binary to hexadecimal conversion. So this is what I want to tell you in this video. Okay, so what we do in this video, I'll showing you how we can convert hexadecimal to binary and binary to decimal to hexadecimal like this. Okay, fine. So that's it for this session, guys. I hope you understand the video. If you have any doubt, anything, please comment me on this video. Okay, and if you have any questions, please comment me on this video. I'll definitely get back to you. Thank you very much, guys, for watching.